Let's take a look at maximizing revenue over an open interval. So that means we're going to do the absolute extrema in an application. So here's the question. Recall the revenue equals, and you're like, oh my gosh, it's one of these kind of problems. Remember, you're going to read through these 3 times. The first time, you're going to put yourself in the neighborhood. So what is it they're even talking about? Does the scenario make any sense? Then the second time through, what are they asking you to find? Have you done that before? Is it something similar? So it's making sense. And then the third time that you go through, you're going to write down some things that you're trying to find and any information that they give you. So let's take another look. It's recall that revenue equals price times quantity. So that means revenue for the following demand function. So here's the demand function P in dollars. And so you read through the whole thing, then you read through it again, and they're asking you to find the price that maximizes revenue. You've done that before. You know revenue equals quantity times price. And we have to round to the nearest penny. So pause the video, read that through again so you know what it is we're looking for. And what information do we know? We know that X is the number of units that we're selling. P is price in dollars. And they're giving it to us like this. We need the revenue. And the revenue, again, is quantity times the price. So that means quantity is X. That's what they're telling us here. And times the price. And the price they give us is 60 minus 0.03X. Go ahead and distribute that. And we get this. So that now gives us number of units, price in dollars. Here's the formula they gave us, and here's the revenue. Remember, the question is asking us to find the price that maximizes the revenue. So we're going to need to go and find that max revenue, the X that maximizes that, and then we're going to have to substitute that back into the price. Here are the functions that were given up here. And so again, revenue, we'll write it as revenue of X is 60X minus 0.03X squared. We need to take that derivative and look for the critical values. So R prime of X is equal to 60 minus 0.06 X. We brought that 2 down, multiply it by the 0.03 to get 0.06x, sorry. We set that equal to 0, and we're going to solve this. So let's add that 0.0x to both sides. Then we're going to divide both sides by that coefficient of x, and that's going to give us 1,000. Now, since it's on an open interval, we have exactly one critical value for all real numbers, right? And that also means, because of our absolute value extrema that we're looking for, we can now use the second derivative in concavity to figure that out. So let's find the second derivative of the revenue. So we're taking this guy and finding his derivative. And we do that, we get negative 0.0x. Because you bring this coefficient only, he has an exponent of 1. And this guy is less than 0 for all real numbers. What that means concavity-wise is that this is facing upside down, and we have a max here at whatever x was, and that's 1,000. And so the question was asking us to find the price. What we found was the quantity. Now we have to substitute into the price. So the price is equal to 60 minus 0.03x. Let's go ahead and substitute in our 1,000. And when we do that, we get 30. And so our final answer is that we should charge $30 per unit to maximize the revenue. And that's it. And so if you have questions on that, you should go back through and listen again. Hope you're having a great day.